Children, I'm going to talk about the buffer solution, but before moving ahead, we need to discuss one very important phenomena that will be used in buffer solution is common ion effect. Now, what is this common ion effect? Let's discuss it. What is common ion? First of all, I'm writing the definition here of common ion effect. Let's do it. The suppression, the decrease, or fluctuation in the activity of weak electrolyte in the presence of strong electrolyte. Right, or one more definition that we can include here is the separation of electrolyte. So the decrease in the degree of the common ion effect, or a decrease in degree of common ion effect, or decrease in degree of common ion effect. We will be discussing this decrease in degree of common ion effect. Now, what does it say? It says that very important that both should have common. Both should have common ions. Right now, what does it say? It says that let's take the highlighter for highlighting it simultaneously. Yeah, let's take a white. It says that the decrease in the degree leads to, which means the strong electrolyte suppresses the activity of the weak electrolyte. There are giving example here. The activity of the weak electrolyte and it actually disturbs its equilibrium in the presence of a strong electrolyte, or decrease in the degree of common ion effect. But if we talk about strong, or if we talk about strong, for example, and if you're talking about weak, they should have common ions. They should have common ions. They should have one thing, that is common ion should be there equal, right? So separation is the activity of the weak electrolyte in the presence of strong electrolyte. Let's discuss the example here. So let's just read it. Let's start. Okay, I'm taking an example here for discussing it. Let's take example. For example, NH. Okay, just leave it. HCN, we can take HCN as well as the weak acid. HC hydrogen syncate. It's breakdown into H plus and Cn minus. But what happens simultaneously, we add one more solution or one more component in the solution. For example, it's present inside the solution. We are adding one more component inside the solution, which is let's take example of CH3COO, which is CH3COO, CN. Right. This is a salt of weak acid and strong base, which is one of the criteria of buffer solution. This is we were discussing what is buffer solution, but CH3COO and SCN. So this is basically a salt of weak acid and a strong base. It breaks down into CH3 C double bond. You're not now making the structure here. C double O minus plus CN. It breaks down into it. And when it breaks down into this solution, for example, now it is in equilibrium condition. But now what exactly happens, that when it increases in the solution, we know that it will dissociate 100% because this is the only forward reaction. So this dissociates 100%. No doubt it will dissociate 100%, but it dissociates in a very little amount. And when it increases in the solution, this will part. When it increases in the solution, this combine with HCN and convert into HCN, due to which a very little amount of HCN is forming, due to which hydrogen is has been used throughout the process. So this is basically a separation in the activity of a weak electrolyte. You know that this is a weak acid, which means a weak electrolyte. This is weak. We know that it's weak in nature. And what's happened is when a strong salt or weak acid and strong base combine, break down, it breaks into this and this, and since it's a only forward reaction, the hydrogen combined with this uh, uh, syncate and form and this converted into hydrogen syncate, right? So this is basically the operational activity of uh, weak electron in the presence of strong electrolyte. Let me discuss one thing more with you. Take a ball here. You can easily visualize it. If you take an example, let's take a shape here. That will be more easy for you to understand it, right? Let's increase its size. Let's just fill it with any color, any light color or any color. Okay, it's not perfect yet. Just visualize it. This is filled with completely with color. Take a ball here with different color. This container is filled with water, and then now take ball. This is ball basically I'm coloring. When you displace this ball from this position, it goes here, or it goes here, or it goes here. But ultimately it fell down to this regional position, which means this ball always wants to achieve its equilibrium position, right? So the same happened in the buffer solution as well. The ball always a compound or the reaction always try to achieve its equilibrium position. Due to disturbance separation in the activity, it changes into the forward and backward reaction starts to ventilate the very achieve an equilibrium position, right? So let's, because now we are done with the common ion of